Okay, student. Today our topic is interrupts in 8086. In 8085, we have studied the function of interrupts. So, an interrupt is a condition that halts the microprocessor temporarily during program execution and allows peripheral device to access the microprocessor. The microprocessor responds to that interrupt with an ISR interrupt service routine, which are short program to instruct the microprocessor on how to handle the interrupt, right? So interrupt basically a halt service routine, and ISR, that is interrupt service routine, which is a short program to instruct the microprocessor on how to handle the interrupt. ISR is a program that tells the processor what to do when the interrupt occur. After the execution of ISR, control return back to the main routine, and the main routine goes as usual. So the microprocessor encounters an interrupt follows task. When an interrupt occur, the values of flag register is pushed into the stack. It means that first the value of stack pointer is decrement by 2, then the values of flag register in the execution unit is pushed to the memory address of stack segment. The values of starting memory address of CS, that is code segment, is pushed into the stack. The values of IP of instruction pointer is pushed into the stack. After that, IP is loaded from the word location. Interrupt type code segment is loaded from the next word location, and interrupt and trap flag are reset to 0. So interrupt basically are two type, one hardware interrupt and software interrupt. And hardware interrupt is basically and two type, maskable interrupt and non-maskable interrupt. Maskable, what is the meaning of maskable? That is, that interrupt can be controlled, and non-maskable, that is uncontrolled. When an interrupt occur, then that means you have to stop the previous program. Now the we move to the hardware interrupt. Hardware interrupt is a caused by any peripheral device by sending a signal through a specific pin to the microprocessor. That is, here the pin is specific. The 8086 has two hardware interrupt, that is NMI and INTR. NMI is a non-maskable interrupt and INTR is a maskable interrupt having lower priority. That is, maskable interrupt is INTR and NMI, that is non-maskable interrupt. One more interrupt pin associated is INTA, called interrupt acknowledge. So now we move to the NMI, non-maskable interrupt. It is a single non-maskable interrupt pin having higher priority than the maskable interrupt request pin, that is INTR, and it is of type 2 interrupt. When the interrupt is activated, this following action take place. Complete the current instruction that is in progress, pushes the flag register value onto the stack, pushes the code segment value and IP value of the return address on the stack. IP, that is instruction pointer, loaded from the content of the word location 00008H. After that, CS is loaded from the contents of the next word location, that is 0000AH. A means 10. Inter flag and trap flag are reset to 0. Now INTR, that is maskable. So the priority is less. The INTR is a maskable interrupt because the microprocessor will be interrupted only if interrupts are enabled using set interrupt flag instruction. It should not be enabled using clear interrupt flag instruction. The INTR interrupt is activated by an output input port, that is external peripheral. If the interrupt is enabled and NMI is disabled, then the microprocessor first complete the current execution and send 0 on INTA pin twice, that is INTA acknowledge, that is interrupt has been acknowledged. The first 0 means INTA informs the external device to get ready, and during the second 0 the microprocessor receives the 8-bit say X from the programmable interrupt controllers. So INTR action are taken by the microprocessor as follow as this. First, complete the current instruction. Earlier I have told activates INTA output and receive the interrupt type say X. Flag register value, CS value of the return address and IP value of the return address are pushed on the stack. IP value is loaded from the content of word location X multiplied by 4 location and multiplication by 4. CS is loaded from the contents of the next word location. Interrupt flag and trap flag is reset to 0. Now, software interrupts. Some interrupts are interested at the desired position onto the program to create interrupts. That means when we creating or writing the program, we are introducing desirably a interrupt. This interrupt instruction can be used to test the working of various interrupt handler. So this software interrupts is mainly of three types, that is INTA interrupt instruction with type numbers, INT3 breakpoint interrupt instruction, and INT0 interrupt on overflow instruction. Mainly we will discuss the first one, that is INT interrupt with type numbers. It is 2-byte instructions. First byte provides the opcode and the second byte provides the interrupt type number. There are 256 interrupt type under this group. Its execution includes the following steps. Flag register value is pushed onto the stack. CS value, that is code segment value of the return address, and IP values of the return address are pushed onto the stack. IP is loaded from the content of the word location type number multiplied by 4. CS is loaded from the contents of the next word location. An interrupt flag and trap flag last are raised to 0. The starting address of type 0 interrupt is 000000H. That is type 0. When we type 0, the starting address for type 0 interrupt is 6000000H. For type 1 interrupt, it is 00004H. Similar for type 2, it is 00008H, and so on. The first 5 pointer are dedicated interrupt pointer, like type 0 is interrupt representation division by 0 situation. Type 1 interrupt represents signal step execution during the debugging of program. Type 2 interrupt represent non-maskable NMI interrupts. Type 3 interrupt represents breakpoint interrupts. Type 4 interrupts represent overflow interrupt. The interrupt from type 5 to type 31 are reserved for other advanced microprocessor. As I have told earlier, the software interrupt is basically a 256 type. So after 4, that is 5 to 31, is reserved for advanced microprocessor. And interrupt from 31 to 255 are available for hardware and software interrupt as well. So this is the 8086 interrupt, and last two types software interrupt is INT3 breakpoint interrupt instruction and INT0 interrupt on overflow instruction. So all total, this is the interrupt in 8086 microprocessor. Thank you.